And now I'm going to clear again, and then I'm just going to go through and do just a few more balancing of equations. And I think most of you are, you've been doing this like for the lab and stuff, and I think most of you got a pretty good handle on it. And logically, it's like a very um, simple concept. You just have to make sure that you have the same number of each atom in the reactants and products. However, some are much more tricky to balance than others. For example, like I picked this one out because it's got oxygen in two different um, compounds in the products. And that does make it trickier because you have to take into account both of those. So you really have that, you have to look at these, and then there's some certain steps to do this, and it makes it a little easier. So the one thing I always do is if I see there's two oxygen and two different compounds, I save that for last. And then if I also have a element that's not diatomic, like not O2, I also save that for last. Basically, I do these later because they're hard, and then if it's like just a single element, I do it later because it's easy to just like balance after everything else. So anyway, for this one, I'm going to save oxygen for last. So I could start with nickel or sulfur. It doesn't really matter which. So let's say nickel. So we've got one nickel here and one nickel here. So that looks like it's balanced. And then we have sulfur. So there's one here and one here. So that's balanced. So that was pretty easy. But if we go to oxygen here, we've got two here. So we already did the easy ones, basically. We've got two oxygens here, and then we've got 1, 2, 3 here. So this is the tricky part. So now I'm going to, we've got 3 oxygens here. So basically, we have 3 halves of one of these, right? So if we multiply 3 times 2, that's 6. And then divide by 2, that's 3. So that would be 3 halves of an oxygen will give this, then it will be balanced. So that is balanced, but that's not what we want to do. Instead, we want to double everything. So basically 1 is going to become 2. So it's, I didn't write the 1 here, but we'll make that 2. And then this one I'm going to erase. Yeah, I got an eraser here. Okay. And so that's going to be, it was 3 halves. So we're going to make that 3. And then we've got 2 and 2. So that's how you do one like that. And then let's go on to the next one. So for this one, if we look, doesn't look like anything. Oh, actually, there is something. The chlorine in this one is in 2 different compounds. So we're going to save that one, or at least one compound, and there's also just a diatomic chlorine. So we're going to save that one for last. Let's start with manganese. There's 1 and 1. So again, we don't have to do anything there. I could write a 1, but I don't have to, and I'm not sure if I'm going to have to change this one or not. We'll find out. Oops, that was the wrong place. Okay, so right here. So 1 manganese here and here. Now we can do oxygen. So it's O2. So in this case, we're going to need, there's only one compound or one product that is oxygen is this one. So that's 2O2. And now we've got H2 here. So there's 1 H here, and we've got 2 times 2 is 4. So that's 4 HCl. And then we have, so 4 there, and then we've got 1, 2, 3, 4. So I think that is balanced there. But I'm going to check my work. It's always good to check because it's easy to like make mistakes. So we have here 1 manganese, O2. There's going to be 2 of them. Oh yeah, and then there's actually, yeah, so it is not, this is not balanced yet. So we've got And that's why you do this, because like when you go back, sometimes you end up changing things. So now we've got, wait, oh no, that's okay, because there is 2 here. So that's 202, 202. Then we've got 4H, and then 2 times 2 is 4H, and then 4Cl. And again, this is a tricky one because it's 2 chlorines here and 2 chlorines here, so that's 4. So that is balanced. And then we'll move on to the last one that I have here. So for this one, we have oxygen is in 2 different compounds, so that's going to be a tricky one. And then we have this polyatomic ion, and it's actually being formed. It's not on this side, but it is on this side. Sometimes polyatomic ions kind of stay in the from the products to reactants, but that's not the case here. So I think I'm going to leave, I'm just going to do carbon first, although carbon looks pretty easy. So there's 1 here and 1 here. But I have a feeling that's, I'm not sure if that's going to be how it ends, but let's see. So then we have NH3, but if we look over here, it's NH2, 2. So that means there's 2 nitrogens here. So we're just going to have to write 2 here. And then we have 2 times 3 hydrogens, so that's 6 hydrogens. And this is another one that's tricky because hydrogen is also in 2 different compounds. So it's 2 times 2 is 4 here, 5, 6. So it actually is balanced at this point. And then we've got oxygen. There's 2 here. And then again, this is in 2 different compounds, but there's only 1 here and 1 here, but you add those together and that's 2. So this one is already balanced. And it looks tricky, but it ended up being balancing out fairly easily. Some of them are much harder. But for the most part, the ones that I would give you are not too much harder than, like, they're about like the ones you'd see here as the hardest. So that's all I have to say about homework 3. That should pretty much give you an idea of how to do it. And then I'm just going to go, hang on, I got to clear this. Yeah, so this is the study guide. And I just want to emphasize, you can get 10 points for doing this study guide, and it's also a good idea because basically if you do it, you're going to have, it's an open book exam, and you're going to have information that you need for the exam. And make sure that you also have it either printed out or on your computer screen, that you have these bits of information here. I have on the top, because you will need these for the exam. So basically, you should be able to know how to calculate the difference in electronegativity, and also what that means, that we have, if the difference is greater than 2, we have an ionic bond. If it's between 0.4 and 2, we have a polar covalent bond. And if it's less than 0.4, we have a non-polar covalent bond. So you will need to use these, and make sure that you know how to use them. Then also make sure that you understand this table. So all this stuff about molecular geometry, you do not need to memorize. You just look at this table and it will tell you. And you should be able to figure out like the number of electron groups. And I'll just point out that if you do the study guide and the lab, basically you're going to have all the information you need to answer questions on the test. So make sure you have that. And once you do, be able to recognize what an electron group is. So a double bond is an electron group. So this compound here has 1, 2, 3 electron groups. Even though there's 4 bonding electrons, since 2 of those bonding electrons are in a double bond, that's 1 electron group. So that's 3 electron groups. All of them are involved in a bond between 2 atoms. So that's 3 bonding groups. And if we go down here, we have, this is a lone pair of electrons on top. When you see those 2 dots, that's a lone pair. So that is not a bonding group. It is a pair of electrons. We've got 1, 2, 3, 4 pairs, but then there's only 3 bonding groups, 1, 2, 3. So make sure that you can use this table, and if you have any questions about it, let me know. And then also the mole conversion factors. Um, so make sure that you know, understand that you use Avogadro's number, which this is the number here, to figure out the number of molecules if you have moles, or particles. I should have written particles here because it can be atoms. It can be like basically anything like atoms or molecules, or formula units are the most common, but you couldn't use it to measure anything or to count anything basically. So know how to do the conversions, and then also know how to convert from moles to mass. Use the molar mass, can be the atomic mass if it's in a single atom, or the mass of all the atoms added together if it's a compound, to get to the molar mass, or to get from molar mass, or yeah, from the molar mass to moles. And also recognize that basically if you want to get from mass to particles, or particles to mass, you have to go through the mole. It's 2 steps. And basically the mole was designed for that purpose, so that we can go from mass to particles, because that's really a lot of times that's what we want. We wanted the mass of the particles, and the moles kind of is a way of getting from one to the other. And I think that's all I have to say. And I just want to say I'm sorry that we could not meet in person. I'm really glad that we did get to meet in person for half the semester, so I got to know you all. And I wish you luck going forward. I know this is a really hard time for everyone. A lot of people are struggling financially and with sick relatives and worried about being sick themselves. So just take care of yourself.